In this video, I will show you how to condense logarithmic expressions such as this one. And then I will show you how to expand logarithmic expressions such as these. So first of all, you need to understand that if you have the sum of two logs, then that can be condensed as the log of a product. All right, this is called the product rule. If you have the difference of two logs, then that will condense as a quotient. Whoa, the big ink came out by accident, but you get the idea. Now, if you take those two ideas and put them together, then this is what you have. Say if I have the log, and I'll just throw a random base in here. Say if I have the log base 3 of A minus the log base 3 of B plus the log base 3 of C minus the log base 3 of D. I can combine all of these into one log expression very quickly by realizing that all of the positive terms will give me a factor in the numerator. All of the negative terms will end up in the denominator. So since the A is positive, the A term is positive, it ends up in the numerator. The B term here is negative, so it's going to end up in the denominator. The C term is positive, numerator. The D term is negative, denominator. Okay? And then there's one final property that you need to be comfortable with. If you have a number in the front, say if I have a 5 here, I keep accidentally picking the big ink. Let's say if I have a 6 here. This 5 is going to become an exponent. This 6, when it condenses, will become an exponent. So that will make this a to the 5th power and b to the 6th power. Okay? If I have a 1/2, all right, that will also become an exponent, all right? That's going to become the 1/2 power. But the 1/2 power is the same as the square root, so that would be the square root of C. It would be the same thing if I were to have this whole thing divided by 3. If you ever see that, like look at problem number 17, just glance at the bottom of your screen. Just understand that that's the same thing as having a fraction in the front. So dividing by 3 is like having a 1/3. And again, that will become the 1/3 power, which is really the cube root. I need a little extra space for this. Okay, so that's how condensing works in a nutshell. Now, looking at these specific problems, first of all, I see these numbers in the front. When I'm condensing, they are going to become exponents. Okay, so that's going to leave me to log base 2 of x to the 6th power plus log base 2 of y to the 12th power. Now, as I mentioned a moment ago, the sum of two logs will condense down to a single log with a product. So this is going to be the log base 2 of x to the 6th power, y to the 12th power. Okay, take a look at number 16. It's going to be the same type of thing. This 20 is going to become an exponent. This 5 is going to become an exponent. So I could write that as log base 2 of x to the 20th power minus log base 2 of y to the fifth power. And then subtraction condenses down to a quotient. So this would be log base 2 of, and it'll just be x to the 20th power over y to the 5th power. The positive one goes in the numerator, the negative one goes in the denominator. This is the final answer. First of all, understand that dividing by 2 is the same thing as multiplying by 1/2. So I will think of this as 1/2 log base 2 of x plus 1/2 log base 2 of y plus 1/2 log base 2 of z. Does that make sense so far? Okay. So I can use the power rule and take each one of these 1/2s and make them the exponent. Okay. So for example, with this x, I would have x to the 1/2 power. But x to the 1/2 power is the same thing as the square root of x. So this would be the same thing as log base 2 of the square root of x plus log base 2, that's a g, of the square root of y plus log base 2 square root of z. So then I just use the product rule. So this is all addition. So I can write this as a single log base 2 and then multiply these three things together. So this will be the square root of x, y, z. So that's it for number 17. For number 18, again, this 3 will become the exponent, and this 12 will become the exponent. So then we have log base 7 of u to the 3rd power plus log base 7 of v to the 12th power. And then addition condenses down to multiplication. So this is going to be log base 7 of u to the 3rd power, v to the 12th power. Now for the next few problems, let's switch gears and see how to expand a logarithm. We will be doing the same exact thing, but we will be moving in the opposite direction. First, let me just give you a generic example. Say if I have the log of AB over CD. This is going to expand as 4 terms. Anything in the numerator will be a positive term. Anything from the denominator will give me a negative term. So this would give me the log of A plus the log of B. Both of those are positive because they came from the numerator. Minus the log of C minus the log of D. Those are both negative because they came from the denominator. In addition to that, if I had any exponents here, so let me switch colors for a second. Let's say this was squared or this was to the 3rd power. Okay, then that would mean that this would be squared and this would be the 3rd power. But when we're expanding, those exponents are going to wind up in the front. So this 2 from the a squared is actually going to wind up here. And this 3 is actually going to wind up here. Okay, so we'll actually go straight to this. In the same way, don't forget that when we have the square root, that is the same thing as the 1/2 power. And again, that 1/2 power has to end up here in the front. All right, that would be the same thing if I had the cube root, for example. Okay, that would be the same thing as the 1/3 power, but then that's going to end up again in the front. So if I had a problem like this, then this would be the answer. Okay, let's see what happens. Okay, so on problem number 19, we have one little extra algebraic step here. Well, I mean, there's a number of ways we could do this. I think the easiest thing to do is to go ahead and square each of these things before we start expanding things. So this would be the same thing as log base 5 of u squared v to the 12th power. When you raise a power to a power, you multiply. So now when you expand this, this will expand as the sum. So this would be log base 5 of u squared plus log base 5 of v to the 12th power. But of course, we're going to put these exponents in the front. So this 2 is going to wind up here. And you really could skip this step and just go straight to putting the exponents in the front. So then this 12 is going to end up here. Okay, so this should be the answer to number 19. For number 20, let's deal with the square root first. Understand that this is the same thing as w times uv to the 1/2 power. Square root is the same thing as 1/2 power. And then this would be the same thing as the log of w times u to the 1/2 power times v to the 1/2 power. Just went ahead and raised each one of these things to the 1/2 power. All right, now that makes it easier to write in expanded form because now I'm going to just separate this into 3 terms. So this would be the same thing as the log base 6 of w plus, okay, now I'm going to have the log base 6 of u to the 1/2 power. Let's go ahead and skip the step where we write the 1/2 power and then put it in the front. Let's just go ahead and put it in the front right now. So this will be 1/2 log base 6 of u. And similarly, we will have plus 1/2 log base 6 of v. Okay, so this should be the answer to problem number 20. For problem number 21, let's go ahead and apply the exponents. Let's raise each of these to the 5th power before we really get started. So this would be the same thing as log base 3 of u to the 5th power v to the 25th power. When you raise a power to a power, you multiply. Okay, hold on. My parentheses are looking a little janky. Okay, so it's time to use the quotient rule. So this will expand as the difference of 2 logs. So this would be the log base 3 of u to the 5th power minus the log base 3 of v to the 25th power. Now, I went ahead and showed this extra step, but you know what's about to happen to these exponents. All right, this 5 is going to end up in the front, and this 25 is going to end up in the front. So you can feel free to go straight from here to here without showing that step in between. So this should be the final answer for number 21. And for number 22, this one is so straightforward, we really should be able to go straight to the final answer. This is going to expand as the sum of 3 terms. So this is going to be log base 5 of a plus the log base 5 of b plus, And yes, let's go ahead and plan on putting the 5 in the front. So we will have 5 times the log base 5 of c. And that should be the answer to number 22. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.